So the first realistic question that you learned is vectors, though I'll do one question on measurements and units for the sake of those that are doing 10-15, yeah, just for the purposes of your revisions. So under vectors, you learn to say a vector is anything that has magnitude and direction, of course, and you learn to say whenever you are given anything on the x or y plane, so you learn to say a vector can have an x component and a y component, and the angle that we use for us to get the components of a vector or the coordinates of a vector, so when they say coordinates or components, they mean one and the same thing. So this is the formula, or these are the formulas that are needed. And whenever it comes to getting the components, we always measure the angle from the positive x-axis. So if I give you a vector that is in the second quadrant like this, you always have to measure it from this side. You always, even if I give you a 20 here, you know to say your angle is going to be simply 160 because you measure it from the positive x-axis to get the x and the y component. And these vectors can also be added or subtracted depending on the case that you are given. So I'll just do a proper example here to just cement what I'm discussing. To remind you, so look at question number 2, for instance. They're simply saying find the direction and magnitude vector of A and B. So the first thing they want is the vector sum A plus B. That's what they want. So meaning we need to resolve the vector A into its x and y component. The same applies to B. So we have to resolve them first. Whenever you are given a vector, you cannot do anything with it if it's in its raw form where you have the magnitude. Magnitude is just the size. Then when we say direction, we mean the angle with respect to the x, positive x-axis. That's what we mean by direction, the angle that we have. Though of course sometimes they're going to be using the language like northeast, where west, so you have those poles that you have. You can have your north, your south, your west, and your east. And I may remind you to say when they say something is due north, for instance, it simply means it's on the north, right? It's on the direction on the north pole. That's where it is, meaning the angle is 90, because you know this is 0, this is 90, this is 180, we have a 270, just before the 0 mark we have a 360. So if they say due west, meaning just know it's on that particular pole that they're mentioning. Then when they say it's, let's say 30 degrees north of something, north of west, you simply stand on the last direction or the last pole they've mentioned, and you move 30 degrees to the first pole that they had. So we'll stand on west. They said north of west, so we'll stand on west. Then we'll go the 30 degrees towards what? Towards north, because north is somewhere there, meaning this is where the 30 degrees is. Meaning the actual angle is simply supposed to be 150 because the total straight line adds up to 180. Now our angle that we need to get our x and y coordinate should always be measured from the positive x-axis. Yeah, so this is what you do if they say 30 degrees north of west, if there is off between two poles. Then if they say northwest without off or stating an angle, it simply means that we are demarcating west and north half-half. So meaning the angle is simply 45. So in between, you know, west and north, meaning we are cutting it here on the middle, meaning this is a 45 and this is also what? A 45. So please take note of those two terminologies. So just reminding you here, guys, look at this example here, just a quick one. So this example here, they're just saying there is A. So A, we're going to have the components of A. So say, let me just try to draw this to remind you. There's A right here. So we stand on west and then we are going to go 30 degrees towards north. North is somewhere there. So meaning this is our north. So meaning this is where your 30 is going to be here, John. Your 30 is here. So if your 30 is here, remember we said we measure our angle from the positive x-axis to where that vector is. So, meaning we're supposed to stand here and we're supposed to go like this. Meaning the angle is actually what? 150. Because we have subtracted, we've done 180 minus our 30. That's how we basically get our angle. So meaning whatever x is equal to r, you say your cos what? 150. Then you have your other one, you have your y component. Your y will simply be r sine 150. Now if you don't want to use the 150, you can pay attention to the quadrant where that particular vector is. Yeah, so someone who writes 150, this is okay, as someone who also just indicates with respect to the trig ratios. So cos is negative in the second quadrant, only sine is positive. So meaning if I was to write r, then I say cos 30, I need to put a negative in front because the cosine function is negative in the second quadrant. I hope this makes sense, John. Is this okay? You're okay with the 150 where it's coming from, right? So you always have to stand on the positive axis to go to where the vector is. So like this question that is here, this is what you did first when you are starting after units. So like here they're asking for the magnitude and direction of a plus b. So we have to make a table. For you to score your full marks, you always have to be making a table. So you have your a, your vector a, and your vector b. So this is basically what we have in terms of the terms they use. Yeah, so sometimes they can just say in the horizontal, in the positive, meaning we're going in the positive direction this side, or negative, meaning we're going like this. If they say upward, the positive, meaning we're going up. Yeah, so such questions, and most likely they like giving you something like you see something like, which question is that? You have to questions where you have to make your own free body diagram so that they see if you're actually able to follow, like this guy here, like this question here. If you see, they're saying a man pushing a mop on the floor causes the mop to undergo two displacements. The first displacement has a magnitude of 150 centimeters and makes an angle of 120 with the positive x-axis. The resultant displacement has a magnitude of 140 and is directed at an angle of 35 to the positive x-axis. Find the magnitude and direction of the second displacement. So meaning they've given you the first vector and they've also given you the answer, the data, the information about the data. Now we're looking for b. We don't know what b is. Yeah, so we'll just be filling in the blanks. It's like I give you a plus box is equal to b, meaning I'm asking you to get what? To get, or let's say instead of b we use another letter, let's say c. We're looking for what is in the box. So such questions. Now to just assist you, to remind you of what you did under vector. So here we're going to say we need to make the x, I need to get the x and the y component of the vector. So the x component of a will just be, we'll get the 30 meters, then we'll say cos. The angle has to be measured from the positive x-axis to where that vector is. So the angle that we're using for a will be 180 minus 25. That's simply going to be 155, meaning this side will just be 30 meters, then sine 155. Then here, you know, for b, we'll get the 20, but then the angle we need to use is from here up to where the vector is. We're given a 20 already. So from 360, if you remove a 20, that's 340, meaning this is going to be 20 meters, cos 340. Then this will be 20 meters, then sine 340. So this, you just sum up this. We're getting the resultant. So they said a plus b, so we're adding the components. If you add this, you get your answer there. You add up this, you get your y component here. Once you're done getting your x and y component, you can proceed to get the actual value of r by saying r is equal to this, or you can get the angle. The angle is just tan inverse the y component over the x component. Then you get your angle. So hope everyone remembers this. I was just trying to remind you what you did in vectors, because we need this. I said I'm going to start with Newton's laws, then we'll go back projectile motion and everything else that you need. So aside from measurements and units, vectors is one of the important topics that you have, and this is basically what you have. You will always do this. So if they have not specified what you're doing those vectors, just know to say you're adding them. Yeah, they'll just say add. So maybe let me show you this guy here. So because I don't have a calculator, I'll leave it here, but you can punch 30 cos 155 plus 20 cos 340. So we add the x's and also add the y's separately. Yeah. Any questions, guys, here? Is this okay? John, is this okay? Oh, yes. Yeah, so for the purposes of your test, it's best that you show your answers like this. You have to make the table big enough so that when you are solving, let me just change this. You have to make your thing big enough so that you create space for your working. So if you say the first one was what was it, 30? This is 30 meters cos the angle that we had, which is what, 150 something. You have to show that when you punch this, the answer that you get, you put it down there. Even here, you can show this or redraw another table that shows what you punched, what you got. Yeah, so that's okay. Or you can do it in the same table. Just leave enough space. Yeah, it doesn't matter, because at the end of the day, the r is going to be the same with the theta. But for representation's sake, it's best that you punch and then write in a different table, because we avoid rounding off middle way through your calculation. We want you to round off at the end, so don't round off until it's your final answer. Yeah, so now to just improve that, we're just saying you can actually just punch this 30 cos that, and then you also punch plus this, so that we get something that's very accurate, not a rounded off figure. Yeah, so maybe to just cement that, look at this question here that we want to do. So let me increase. So here they're saying a man pushing a mop on the floor causes the mop to undergo two displacements. The first displacement has a magnitude of 150 centimeters and marks an angle of 120. So this is, let's say, example. This is under vectors. So it's up to us now to make use of the information given. They're saying 150 makes an angle of 120. 120 is in the second quadrant. This is, we'll call this A. This is 150 centimeters. The angle here is simply 120. Then they're saying there's another vector B, but we don't know where it is. There's a vector somewhere here. We don't know where it is, B, such that when we add A and B, we get the following. They're saying the resultant displacement has a magnitude of 140 and its angle is 35 with respect to the positive. So the final answer that we're looking for when we add A and B is actually here. This is the answer that we need. So this is your answer there. Your answer is this R, which is the 140 centimeters at an angle of 35. So we have information about the final answer. We have information about one of the vectors. We're looking for the other vector. Yeah, so here we'll create a table as well. So the table we're going to create will be for A, and will be for B, then will be for R as well. So for A, we're just saying 150. This is 150 for X cos 120. Then this is 150. Then sine 120. Then for B, we don't know, right? So I'll just say BX. Then I'll call this guy BY. Then for For R, we know to say this is going to be 140, then cos 35. This will be 140. This is sine 35. So hope this is okay. Hope everyone is okay with this. Now we're just looking for B. So meaning we have to now flip the equation. So we are done using the table. So now we have to make equations for the x and the y. So now we are having the following equations. We're going to get 150, then cos 120. This is plus the x component of b to be equal to 140, then cos 35. Then we also do the same. We're saying 150 sine 120 plus the y component of b is equal to 140, then sine 35. Then we make bx the subject. We also make by the subject. Meaning you've gotten the x and the y component of b, and once you do that, you can now use them to get your value of b, because the actual value of b will be the square root of the x component of b plus the y component of b, together with the angle as well. The direction will be tan inverse the y component of b divided by the x component of b. On Newton's laws, most likely an incline one. That's a case that you should anticipate, with friction, of course. So now, first and foremost, I want to give us a summary on Newton's laws. So we talked about all the three laws of Newton. Remember the first one, we say if something is at rest, it will continue being at rest until acted upon by an external force or unbalanced forces. This is also applicable for constant velocity. Whenever there's constant velocity, just know that acceleration is what? Is zero. So hope you remember that. Yeah, because velocity is the same, right? So everything becomes zero. Then the second law just says for every force, net force that we experience, we have it in terms of the product of mass and acceleration. So let me put it here. Let me put it alpha. Let me put A, the one that you're used to. Yeah, so we're just saying force is equal to mass and acceleration. So if there are two forces acting on a body, the winning one will take the box in its direction. So if I give you 20 newtons there, and I give you 30, so it simply means that the resultant, the net force causing this object to move is actually 30. We're saying 30 minus 20 is going to give us 10. So meaning the force that is actually responsible for this box to move is 10 newtons, not the whole 30, because from the 30 newtons, we have to use 20 newtons to cancel the other 20 newtons, only leaving us with what? With 10 newtons. This is the force that is causing any acceleration that you will get to experience. Hope that's okay. And because this should explain why you can have an x and a y component, because force is a vector, meaning it's a product of a scalar and a vector, so it has to be a vector itself. Yeah, so hope this makes sense to explain your second law of Newton. Then the third law, the one that is very much interesting, we're just saying for every action there's an equal but opposite reaction. Yeah, so this is basically what we represent it to be. Yeah, so under the last law, there is a part that we discuss friction, to say the reason why objects are able to sit still on rough surfaces is because of friction. Yeah, so friction is a negative force. It always opposes the direction of the particle, the whole object you're dealing with. So if this box is moving in this direction, then would have friction going in the other direction. So we're saying if something is on a surface, for every action is an equal but opposite reaction, meaning if something is in contact with the surface, it has weight. This is your weight. So the weight is always countered by the surface where that object has been placed on. Yeah, so we're just saying the only force acting on this thing, on this box that we're having, is the weight, which is in the vertical. That's what you basically have. So if you want to pull this in the opposite direction, you're applying a certain force, and they say this, the surface is rough or there's friction, meaning you're supposed to get friction. Yeah, and friction is very straightforward. Whether kinetic or static friction, it's just mu. Then we have your mg. So this is basically how we get the friction. And of course, there are two types of frictions. So there is kinetic friction, and there is it. So this is Fk, and there is static friction. Any questions, guys, up to this point? This are not smooth. There are ways to reduce friction. There is lubrication. Then you just have good. It increases the efficiency of your device. Yeah. So a practical illustration is this one that is here. So applications, I'll go through the one that you should expect, which is the incline, of course. So I'll give you the principles here before we actually solve one example. So on the incline, we know to say, or you should know, that whenever an object is on the incline like this, it wants to really decelerate down. Yeah, because that's the normal way of things, because of the weight, right? If you just put something here, if left unattended to, this thing can actually just reach down. Yeah, so if you put something here, which is this box in this particular case, naturally this thing wants to fall down. It wants to decelerate down. This is why you're seeing the mg sine theta. It's always going to be a force that is pointing down. Now if there's friction, meaning this thing would dilly-dally, meaning there's friction there. Now even if here, this is what you get. So friction always occurs in the opposite. Even if this thing is already going down, there is still friction. Just that the friction may be minimum, because now, yeah, so this is what we have. Okay, so we're just saying the frictional force is mu, then mg. We know normal force is equal to mg. Then we're saying the winning force is mg sine theta. Friction is losing, because either way this thing ends up moving down. So the winning force is mg sine theta minus friction, which is mu mg, and this is equal to, this always gives us ma. This is what we have. The winning force minus the losing forces always lead us to get ma. You notice that that's the reason why masses were not given, because they knew to say we can actually cancel. So this here, this is mu, so mu times g, then plus subtracted from this is equal to a this side. Yeah, so yeah, this is basically what we have. So if I give you this, maybe let me just try to see if you're following here, guys. So the way questions are going to be given are going to be in a different manner as compared to what you've learned, obviously. Yeah, so question number 30, they're saying a block slides down in rough incline sloped at 40 degrees from the horizontal and schematically illustrated in the diagram below. Starting from rest, meaning initial velocity is 0, it slides a distance of 0.8 0.800. This is the meters they're saying. The distance, the time that you take there is 0.6 seconds. Then for this thing to fall down, this minimum distance, yeah, this is what we are having. Then they're saying, what is the coefficient of kinetic friction for the block and surface to 1 decimal place? So because we're starting from rest and our distance has been given, the time has been given, so what else is remaining here if this is a system you are given. So you have to determine, yes, Chris. Yes, Chris, this guy here. It's just F. Yes. It's the same one. You've seen what I've written here, Kriska. So we are adding them. You're saying that even if we add them, we're still going to subtract them from F, because it's like munga chena chache distribute negative. If I multiply with a negative, this is what you get. So other people prefer writing it like this, because these two are together, they're doing the same work, they're trying to achieve this guy going down, but the one that is trying to pull it up is this guy. Yeah, so whether you say you're adding these first, then subtract from there, or subtract each one of them separately, in same nachmosmos, this is what you have here. You see it, ka? Yeah, so all in all is that we're going to subtract them. So whether you're going to add them first this side, then subtract them from the winning guy, or subtract them independently, the outcome is still going to be the same. Yeah, so this, some people will go with this other guy. Okay, so the thing with physics, guys, don't let concepts be strange to one another. Like, make the concepts overlap. Like, you noticed how I figured that the acceleration here we have to use the equation for distance, because now you're wondering to say, why are we given distance in this guy here? Why are we given distance and also initial velocity and time if you're not going to use them in this expression? They are known here, there are two of them. We're looking for mu, but acceleration is also unknown. So I'm using the information given, which is I have my initial velocity, I have my distance, I have my time, using all the equations that you have at your disposal, because you just don't know which equation may actually work or work out. So you need to have everything on your fingertips. That's what we're trying to do here. Yeah, all the concepts are interrelated. So here I was saying, on this system, in this type of application where you're dealing with a pulley system, you always consider the one that has more mass to be the one that is going to cause the direction to favor the same big mass in terms of direction. So if M2 is heavier than M1, meaning the whole thing will move like this. And if it's moving like this, you're going to cut it on the middle. So when you cut it, you are demarcating M1 and M2, but they have something in common, because these guys were moving at the same time. When this guy moves down, this guy moves up. Yeah, the same acceleration. So now we're just going to have tension. So according to this, with respect to the M1, and if it's going up, meaning tension is winning. So tension is winning minus the weight 1 is equal to M1 times the acceleration. For this other part, weight is winning because this thing is going down, right? Weight is winning, tension is losing. So say M2G minus that is equal to, this is going to give us the tension minus, or the weight, the weight is one winning, right? So the weight minus the tension is equal to M2A. This is what you have. Yeah, so this is basically what we have. Then we're going to solve them simultaneously or use substitution. You get the two guys that are needed. So this is how you do handle a pulley system. Hope this helps a bit, Mapalo. Yeah, so a pulley system is just like a coupled system, like it's a couple. These are coupled objects, so they are like this. If I was to give you this, yeah, I call this M1, I call this M2. Yeah, so this, yeah, so okay, let me just say, So here we're saying whenever you have two coupled objects, the direction of course will be stated in which direction this thing is going to be moving. So we can treat them as one thing. You can add, we're saying the force is equal to the two masses added together times the acceleration. Yeah, so any questions here, Mapalo, on the pulley system? Is this okay? Yes, Macno. You're able to visualize what you learned and be able to relate it with everyday activities. So like here they're saying a 3 kg syringe box is pulled upward by means of an attached rope such that its acceleration is 2.2 meters per second squared as shown below. What is the tension T of the rope in newtons? So this thing is going up. So it's like I give you that question from your elevator thing. So I give you to say something here is going to go up and the acceleration is going to be moving with this. Yeah, is this. Yeah, so we're having 2 point. Okay. Okay, so this is just a minute. Okay, so the acceleration is given there. This is our acceleration. That's what we have. So now we know to say for this thing to move, so you can just read the question. They're saying this is pulled up, so there is tension there. Of course, there was weight. We had to counterweight, meaning the tension that we are having is the one that has won because this thing is going up. Tension in the rope minus the weight is equal to MA. So the tension is just equal to mg plus ma. Yeah, so the tension will just be 3, then 9.8 plus 2.2. Yeah, then you punch this. So we follow the direction that we have. Now they've told you to take this as positive. Yeah, so we're going up, meaning acceleration is positive. Yeah, so tension is winning as compared to the weight. So you have something like this as your expression, your equation. Any questions, guys, on Newton's laws? I've talked about cases where there's friction. I'm sure for those that are doing 10. Yes, Chris, you're saying? Oh, the mass is given. The mass is considering to be, well, I mean, we're taking it to be 3 kg. Yeah, so this is case 2. They've given you the mu to be 0.4. So we're going to handle it in an event where there's no friction, and if there's no friction, we treat this as if it's one object. We'll say the force is equal to the 2 masses added together, then multiplied by the acceleration. So the 2 masses are simply 5 by, that's going to be 7. Then this thing here will be, okay, that's going to be 35. So this is going to be what we're saying. Oh, we are adding, sorry, we are adding here, guys. We are adding. Let me just do it here separately. So there's a force here that we're using to pull. There's tension there. This is what, the 2 kg. This is the 5 kg. Yeah, so the force that we're using to pull this thing with is, they're saying 40 newtons. Yeah, so 40 newtons is equal to the 2 guys added together. That's a 7, then times that. So we want to get the acceleration first. Yeah, so you divide this, you get your acceleration. I'll put it the way it is because I don't have a calculator. This will be this is meters per second squared. Then from here we are saying we're looking for the tension, so the acceleration that these guys are feeling is the same. So if I cut it off here, this will just be moved by tension. Tension will be equal to the mass times the acceleration. The mass is a 2, then the acceleration is just the 40 by 7. So this will give you the tension. Yeah, so this is when there's no friction. But if there's friction, we'll cut it here and then treat them two separately, because now this guy here will have T and there will be friction. The friction of the smaller mass is not a lot as compared to the friction of a bigger one. So here we're just having, this is just this. And also the force which is causing it to move, because it's correctly connected here. So when we, okay, so this is equal to, the friction here will be here. Yeah, so meaning this force, the winning force, the force causing them to move, minus tension, then minus the friction, then we equate everything to MA. That's basically what you have. Any questions, guys, here? This is how you would have done it. Once you get your acceleration, you can just replace it there and then get your tension now. Yeah, so this is how you would have done it. Then you get your tension as well. So however you manipulate it, let the equations make sense to you. Yeah, and notice that the frictions, don't be tempted. The surface is the same, but don't be tempted to use the same value, because the frictions are really different. Any questions, guys, here? Okay, so if there are no questions,